Hi Keely, sorry you're having trouble with the similarity triangles. I want to try and go through and see if I can do anything to help. So I want to go through and just give you a brief lesson on it. I'm also going to email you a couple links that also have lessons on it, and hopefully together we can all find some way to make it help. I wanted to start with a couple examples. These are just in a textbook that I use, but I wanted to show you kind of how it presents it. We need to figure out if the two triangles are similar. Okay, that is very similar to question 1 in the essay, or question 1 in the quiz. And you got it correct. You said yes, the sides are proportional. And I wanted to just verify that that was correct. If we have two triangles here, we look at the sides. Okay, this one is 1, 2, 3, 4, and this one is 1, 2, 3, 4, 5, 6, 7, 8. So we know that one side is 4 and the other one is 8. This one is 1, 2, 3. So the bottom side is 3, and this is 1, 2, 3, 4, 5, 6. 6. Now we're told that we're given a bunch of things like side, angle, angle, stuff like that that I'm sure you've heard. What that basically says is if we have one side and an angle with another side that matches, so that side and that side, ED and HG, are proportional. So the 4 goes to the 8 and the 3 and the 6, so it's times 2 times 2. But we also have this 90-degree angle right in the middle here. So side, angle, side. And the angle is the same in both too. So with that information, we don't need to see if this one's proportional or not. Okay, we already know that this is a similar triangle because the sides are proportional. And it seems like you're getting that pretty okay. I didn't see any problem with that. If we continue on, in question 3, you're asked a similar question: are the following triangles similar? Justify your answer. And you were given these triangles here, and your answer was yes. Or let's see. The question, this one actually got wrong. I'm sorry. The question is, are the two triangles similar? And you put 1.3. So right there we need to look at the question, are they similar? Are they proportional? And we look here and we see, okay, this angle correlates with this angle right here. Okay, so D and G are the same angle, and H and E are the same angle because we see the two lines. So that tells us that this number, or this side, and this side are the same thing. So we go from D to E, 1 to 2, one line to two lines, so G to H, and we find out that in fact they are, or that those sides are the same. And so we say, okay, this side is 6, this side, the other one, and it goes to, 10. Okay, so now we need to see if the other side is proportional too. This one goes from 1 to 3, but that one does not go from 1 to 3. So what do we need to do to find out if they are similar? Can we tell by the length of the sides? The answer is no, because this goes 2 to 3, so this one right here, I'm going to put it in a box, would go right here. But that doesn't help us at all because there's no measurement here and there's no way to find a measurement. Just like here, and I'll do this as like a wiggly circle, goes right here. So we see that there's no way with lengths to find out if their measurement is correct. But the one thing that you can find out is that all the angles are congruent or similar. They're the same. So the angle D and G are the same. Angle D equals angle G. They're congruent. Okay. Angle E and angle H is the same, and that's what those two lines mean. The two lines tell us that that angle and that angle are identical. So we have angle E and angle H are also the same thing. Okay, and if we move on, this has 3 lines and this has 3 lines, so that tells us that this angle and this angle are the same. If we put them right up next to each other, they'd be the same. So we see that angle F is the same thing as angle I. With that information, we can determine that these angles are congruent, or excuse me, similar, not congruent because they're different sizes. But we can tell that they are similar based on angle, angle, angle. Okay, and that's where a lot of people end up getting lost right off the bat, is how do I determine? Do I, is it angle, 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 side, side, angle, stuff like that? And I'm going to send you a link to a website that kind of explains that in a lot more detail so that you can kind of see what it's talking about. But based on angle, 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 we can see that these two triangles are in fact similar. Okay? Because that's congruent, and that's congruent. So that's our answer. We're not trying to find any measurements or anything. We're just saying yes, it is congruent, or excuse me, yes, it is similar, or no, it's not similar, and why. Okay, so that's that question. As we keep going through the quiz, just kind of looking to see how things did. Question 4, you also got incorrect. And we look at it and we say, okay, given that angle ABD is similar to ACE. So we have the angle here, ABD. Okay, so there's one angle. And I'm actually going to color these so you can kind of see the difference here. ABD. There's one angle. When we look at the other angle, it's a different color. Like that. So we see the two different triangles. They have these parts of those sides in common, but the rest of them are not. Okay? We're told that they are similar. Okay? If we're told that they are similar, when we're given that information, that means this is the same angle as that. This angle is congruent with that. And that angle is congruent with that angle. Okay, so A with A, B with C, and D with E. What is the value of X? Round your answer to the nearest tenth. Okay. Now, when we do something similar to this, the point that we're trying to get through is that, just like you said in the beginning, there's a ratio thing going on. We can find out, hey, with this ratio, we can find out what's going on. So I would like to use this as an example. Okay, and then we'll come back to it. If this man is casting a shadow, and that shadow is 3 feet, and he is 6 feet. Okay, so 3 feet, and he stands 6 feet. We know that somehow that's got to be equal to the same thing. So the 3 feet was on top, so the shadow has to be on top. 25. So I'm putting the shadow on top, okay? And now we're doing the height. The height was on bottom, the height was on bottom. In order to solve this problem, we're going to want to cross multiply and come up with an answer using cross multiplication. If you don't remember what that is, let me show you really quick. We'd go through and say, okay, if we were to cross multiply those, and I'd say, okay, what is 3 times h? Well, that's just 3h equals And what's 6 times 25? Well, that one I'll even use a calculator just because I want to make sure it's right. It's 150. So we see that we put the two separated by an equal sign. So multiply the 3 times the h and the 6 times the 25. Okay, now we solve it just like algebra. Okay, so we would divide by 3, and we see that h is 50. So we know that the height of this building is 50. Using the same ratios that you were talking about when you were getting them right at the beginning, and then you just cross multiply. But you got to make sure you get them right. If you put the shadow on top and the height on the bottom, then the other side also has to have the shadow on top with the height on the bottom. Okay, so the ratios have to be set up the same. So let's look at this one. These are the same, and there's our, distance of the shadow. Okay. So let's just see. Okay, we've got shadows going on here, and we're using a mirror, so they're just kind of backwards. That's just them trying to confuse you. What can we do? Well, we need everything in feet, and that's in inches. So I'm going to say 8 feet is 0.66 inches. So that's 8 inches is 0.66 feet. So I'm just going to change that to 5.66. Okay, and I did that by doing 8 divided by 12. Because that's the fraction, 8/12 of a foot, right? There's 12 inches in a foot, so 8/12. So that's 5.66 repeating. I'm just going to round it to 5.66 or 67 if you want, okay? Because I guess you got to round up. Anyway, so let's go through and see what we have. If we take the shadow on top, okay, shadow is 24. The height on bottom is n. So now on the other one, we take the shadow on top, and we take the height on bottom. Always, the same one on top, same one on bottom. Then you cross multiply, and you get 7 times n, 7n equals 24 times 5.67. 24 times 5.67 is 136.08. Okay, now we're just going to divide by 7, and we see that that is 19.44 feet. And when we round it, the closest height, we see 20 and 19 are all pretty close to each other. So that's how we use the ratio to find the answer. So let's go back to the question and see what we have. We need to find out x. Okay, that's what we're trying to find. With that in mind, I'm going to help you set it up, but I'm not going to solve it for you, obviously. But I want you to I'll solve it. I'll help you go through it. If this side is 6.8, what's the similar side right here? Well, we don't know because it's y. See how they have that down there? So we don't know the full length of that side. Okay. Is there anything that we're given? Is there any information that we have right in front of us? Well, we do see that the bottom lines are given to us, right? BD and CE. Those are both right there. So we know that what those are. So let's compare those, okay? So we're going to do BD 5.0 And then the other one is 7.4. Okay, so we need to compare those with something here. Let's see, we have another line over here and a line over here, but it's got y and it's got an x. Well, we're looking to solve for x. That's what we want. So I'm going to put x on this side, but we're comparing the smaller one, okay, has x as its side, and the larger one, if you look at the larger one, it's x plus 2.7. Okay, x plus 2.7 is the full length. We don't really care about y because we're asked to solve for x. So let's compare those. Let's see what we think that x probably is. Let's multiply. 7.4x equals, now we take 5.0 times x, you get 5x plus, and 5 times 2.7, I'll do that on the calculator, is 13.5. Okay. As we go through and look at those, now we've got an algebraic problem, and we can start solving. Oh, I'm right off the screen there. There we are. Sorry about that. We've got an algebraic problem, and we can start solving. Let's get x's all on one side. So minus 5x minus 5x, and we get 2.4x equals 13.5. And as we have 13.5 and 2.4, we're going to just divide by 2.4, divide by 2.4, and 13.5 divided by 2.4 is 5.625. Okay, and that's how you do it. So it's just like with the guy standing at the telephone pole. You can, find the missing value by comparison. I'll give you. Let's do another example here. Okay, I want to find out how long x is. So I'm going to take 10 and x. Okay, so 10 and x, because I want the side length. See how I have the side and the side? I want them both on top. Now I've got to get two of the same sides on the bottom. So 10.5 and 21. Let's just do that. So under the 10, it's 10.5, and under the x, it's 21. So you got to make sure the same number goes with the same ratio, the same triangle. Okay? I'm trying to word that as good as I can here. Now let's cross multiply. We get 10.5x equals 210. Okay, so now let's go through and divide by 10.5. And that will tell us what x equals. So if we take 210 divided by 10.5, our answer is 20. So the length here is 20 units long. Okay, so just set up your ratio and make sure you have it set up correctly. Like side A compared to, let me zoom out so you can see a little bit better. Side A and side A are both on top. And then, yeah, you spell side with an S, not a C. Side B with side B on bottom. Oh, then you multiply them, and then you solve for wherever the variable is. Okay, so always make sure side A and A are on top, B and B are on the bottom, and then you're okay. And that's triangle number 1 and triangle 2. So you want these two sides to be from the same triangle and these two. Now you can do it other ways. You can have the sides from different triangles and so on, and it will work as long as you try to keep it straight. The reason why I say they come from the same triangles is because then you can say AB, AB, and you don't have to worry about what's where. Okay, so it seems like that's your biggest difficulty with the quiz or the tests. As I flip through the rest of your answers here, um, number 5, given the two triangles are similar, um, I'll help you with that one. Okay, you said 1.3, but again, we need to find the value of Q and T. So we want to know there and there. Okay, so we've got two values we got to find. Well, let's look at this. Okay, ratio tells us that from 1 to 2 is 6, and 1 to 2 is 10. So side A is 6, and side A is 10. So we're just going to call that side A, side A. Okay, now we need side B and side B. Well, what's B? That goes 2 to 3, and that's T. And that goes 2 to 3, and that's 4.5. So that's side B, that's side B. And if we cross multiply, we'll get 10T equals 6 times 4.5 gives us 27, or divided by 4.5. Oh no, 6 times 4.5. Okay, 27. Sorry, I'm one step ahead of myself. Now we're going to divide by 10, divide by 10. And we see that T is, I think I did something wrong. It's not 2.10. Or 2.7. That doesn't make sense to me. Now, you've got to pay attention to that. If it doesn't make sense to you, then something's wrong. We did something wrong along the way. Because 2.7, these are 6 and 4.5. This side is almost as long as that one, so my number can't be right. So can you go back and see what I did wrong? Okay, I made a mistake. I was getting ahead of myself and I wasn't paying attention, and I made a mistake. And I'll give you a second to see if you can see what I did wrong. First of all, I was off the screen. What did I do wrong? Well, just earlier, I was telling you they needed to be from the same triangle. Okay? 6 and T are not on the same triangle. Okay? 6, A and B are on the same triangle. So I have 6 over 4.5. Remember, side A over B. And then you cross multiply with side A over B. So which one is the same as side 6 or side A? Well, we determined that that one's the same. So we have 10 over T. Okay, so that was wrong, and that was wrong because they have to be from the same triangle. So 6 times T is 6T. 10 times 4.5 is 45 divided by 6 divided by 6. 45 divided by 6 is 7.5. And that is the right answer. Okay. Now with that in mind, I'm going to help you set up the other one, but I'm not going to solve this one. I want you to solve it on your own. Okay. We're trying to find Q. Okay, so that's 1 to 3, 1 to 3. So that's the same thing as here. So that's C and that's C. Okay, so side C. So we're going to do side A over side C. Side A over side C. Okay, again, from the same triangle. Don't make that same mistake I just made. Same triangle. If we do side A over side C, so side A, we have 10 over 12.5. 10 over 12.5. Side A and C, we have 6 over Q. Okay. Now, as you go through, cross multiply and then solve for Q. And that'll give you the answer there. Okay. Sorry for that last mess up, but the next question, number 6, it said if those, let's see, if GOU is congruent, or if GOU is similar to EFN, what do you know about these triangles? Be specific. Okay, you put they are similar, and that is true. But one thing you need to realize is they label them a certain way. G and E are the same angle. So that means angle G is congruent with the angle E. And that also means that O and F are the same. And thirdly, U and N are the same. So all of those angles are going to be congruent. If they're similar triangles, they will all be congruent. There won't be any problems there. Okay? And that's the same thing for number 7. Number 7 is asking the same question. If they're congruent, or if they're similar, what do you know about the sides? So rather than the angles, we're trying to find out the sides. And their ratio, okay? That's kind of what we were talking about before. If they're similar, that means that this ratio for that side is going to be the same as that ratio for that side. You know, side A and side A, and so on. So we see that BA is going to be the same ratio as DO. And that's going to be equal to AD and OG. And that's going to be equal to DG and BD. Okay, so you're just looking for how the sides compare to each other. So BA, that ratio, whatever that fraction is going to be the same ratio, the same fraction as AD over OG. Okay, now question number 8, it asks, are the two triangles similar? And you put yes, that they, or no, you gave a number. You didn't put yes or no. Sorry, I was looking at the wrong thing. And it's asking, are those two triangles similar? Okay, well, we have an angle, we have a side. Let's see if the ratios are the same. So let's label the sides. We're going to call this one side A because we have a triangle here and we have a smaller triangle here. Okay, so if we label it and say, okay, that's side A, that's side B, and that's going to be side C. Let's look through it and see if the ratios are the same. A, the same triangle, is 8 over 24. that should be exactly the same. Sorry, I keep getting off screen here. That should be exactly the same as the ratio for line B. 24 over 36, okay, B over B, in this case, A over A, or no, A over B, wow, I'm doing great, A over B and A over B, same triangle, right? So that's 12, excuse me, because you want same triangle, triangle A, triangle B, side A over B, and then side A over B. So we have side A over B. Now what is 8/24? Well, that's the exact same thing as saying 1/3. What is 12 over 36? That simplifies down to 1/3. They are the same. If they are the same, then the answer is yes, they are similar triangles. Okay, so hopefully this gives you a little bit of ability to go forward and try to find the missing sides and so on. I'm also going to send you a link, or a couple links. So give those a try, look through those, and let me know if this helps or if you need more help.